Hi guys, am I audible?
Yes, sir.
Okay, so we'll be discussing the leftover PPAs from yesterday. I'll start from PPA 10. I guess I'll wait 5 minutes for other people to join. Okay guys, let's start. So all the left PPAs are just recursion problems. So just tell me if you have any doubt. So our first question is write a recursive function named search that accepts the following argument. L is a sorted list and k is an integer. We have to return true if it is found in the list or false. Generally we can just use the in operator, but here you have to write a recursive solution. So guys, can you solve with me? I'll wait 2 minutes for you guys to solve the question.
So here we have to do the binary search or just that obvious search method.
Obvious search will do.
Okay, sir.
Okay guys, this is a pretty easy question. So I'll just start with the solution. So, so again, we're already provided with a sorted list. So this is our base case that the first element, okay, first we'll have to pick the length. That is the length of the list is 0. Then we have to return false. And then we can check the first element is k. If it is, then we have to return true. If not, then we'll search for all elements except the first element. So we are exploring the zeroth index.
Sir, call the function again.
Yeah, yeah. Okay, guys. Any doubts in this?
Sir, can we, in the lecture, professor have used a different method, that indexing based mid, and I have pasted the code in the
So
chat.
that is binary search, right?
Yes, sir, binary.
Binary search is much more optimized in this. But this was so everyone can understand.
Okay.
Guys, any doubts in this?
No, sir.
Okay, let's move on to the second question. So we have insertion sort. Write a function named insert that accepts a sorted list and integer x as argument. It should return a sorted list with x inserted at the right place. Again, another function we have to write is isort that accepts a non-empty list as argument. It should return a sorted list in ascending order. Isort must make use of insert. Okay, guys. Again, I'll wait for a second.
Sir, I have uh, pasted code that I have written in the afternoon.
Okay, Manshu. Guys, do you have any doubts in the question itself?
No,
No,
sir.
sir.
Okay, then let's start with the code. So we have to write two functions. Let's first write insert. So we are given a sorted list L and we have to insert X at the correct place. So if length list 0, base case you'll understand after I write the recursive case. Else we are given a sorted list, right? So we can compare the zeroth element with X. So if suppose X is less than equal to the zeroth index, element at the zeroth index, then we can return X plus L. So this gives us a sorted list, right? X is less than L. So we have made X our first index. We have inserted X at the zeroth index. It's greater than, then we can again use the insert function. And this time,
From 1 to the rest of the element.
yeah. So first we'll have to add the zeroth element and then we can use the insert.
Sir, x should be greater than equal to L of 0.
No, it's less than, right? If it's less than, then I'm adding it to the left. We have to return in ascending order.
So why this is
If that,
return L0 means that will be already there, right? L0 in that sorted.
I have to insert X, right? So what I'm doing is in the on line number 8, when I'm calling insert function again, I'm skipping the zeroth element this time. So we have to add it, right? And x is, we have come to the else condition. We know x is greater than L, so it will come after the element at the zeroth index.
Okay, sir. If we didn't do that, means the list
Yeah,
will
we are
get
skipping
destroyed.
this here, right? In
Okay,
the
okay.
second iteration, we are skipping the zeroth index.
Okay,
Guys,
sir.
any doubts in this? Guys, any other doubts?
No, sir.
No, no, no.
Okay. So this is our insert function. And then we have to write isort. So I mean, what we can do is, if length of a list is less than or
Here we
equal
will
to,
call that upper function for every element.
so you have to write the base case, right? That if our
Yeah.
length is less than one, then we can return the list itself. If we have only one element, the list is already sorted, right? And else condition. I'll explain this in just a second.
L
We
of
have to
0.
insert L0. Yeah. Okay. So what we're doing is, if length is less than 1, that is less than equal to 1, that is we only have one element, then it is already sorted. We are returning that list. If it's not, then we are using both the insert function and the isort function. Then we are inserting the sorted list without the first element, and then we are adding the first element. Okay, so this isort, what it will do is, this will, I mean, we'll recurse through it again and again till we reach this base condition that the length of the list is only one. Then we'll return that element. We have one element. Then what will happen? It will add the second element from the insert function we wrote before. Then similarly, we have now a sorted list of two elements. Then it will add the third element, the fourth element, like that. Guys, is this clear, or should I, use a whiteboard to explain?
We
Clear?
use a whiteboard, sir.
Manish?
Yes, sir, please explain.
Okay, okay. Okay, guys. So, I mean, let's take a list of three elements. Let's say we have 2, 3, and 1. Okay. So, our input to the isort is this list. So, is the length of the list less than equal to 1? No, right? We'll get to this part. We have to insert isort. Now, we are skipping the first element. Okay, this part is clear, right? We're skipping the first element and then we'll insert it after we have this sorted list. Okay, so what will happen is, again, what is our input to ISO? We're skipping the first element and then we have to, add this 2, and these two will go to input to the insert function. So again, in the next iteration, what will happen is length is again not less than 1. We'll again get to this insert part. So now I sort again, I mean, again, we'll have 3 and 1 here, right? But this time the length is 1. So this time the return will be this list itself. We have 1 and we have to insert 3, and we are passing this as an argument to the insert function. So insert function is quite obvious, right? That if the length of the list is zero, then I mean we just have to return that element as a list. If it's not, then we are comparing if L0 x is less than equal to L0. So x is 3, L0 is 1. This is quite obvious, right?
Yes, sir.
Yes.
What will happen is we'll have this. Okay. So you can see, right, that we have two elements. These are now sorted. So I mean, uh, for I sort, now we have to add two, right? 1 comma 3. Again, we are inserting 2. Similarly, we will use the insert function. It will insert it at the correct position. So we'll have 1, 2, 3. So I mean, we are sorting one element at a time. So we are breaking it up till the list is of length 1. Then we are adding one element. Guys, is this clear?
Yes, sir.
Yes, sir.
Guys, any other doubts on this question?
It will take much more time to run, right? Because it is comparing every element and then
So,
sorting.
I mean, there are more efficient sorting algorithms. The most efficient known for all cases is merge sort. But in actually we use quick sort, but I mean, you have to worry about these things in PDS. I mean, we aren't worried about time complexity in programming.
Okay, sir.
Guys, any
Sir,
doubts in this question?
No,
Yes,
sir.
Manish.
sir, I'm
Yes,
joining
Sudhanshu.
late. Can you explain one more time, sir?
Sudhanshu, I mean, I just explained it. You can watch the recording, right? The session is being streamed.
Okay, no issue, sir. I'm just asking. Thank you.
Guys,
Sir,
any
in this
doubts?
question, since
Yes.
array is sorted, can we use like a mid for left plus right sir, in this question?
So, I
Since
mean,
function, yes.
yeah, I mean, yes, you can use, but I mean, this is insertion sort. Like I said, I mean, we have more efficient sorting algorithms, but I mean, just do what the question is required. I mean, what asking it.
Okay, sir.
Guys, no doubts, right? I mean, this is extremely important.
Yes, sir. Clear.
Yes, sir. Clear.
Okay, let's move on. A polynomial is the following mathematical function. AIs are the coefficients.
Sir,
Okay.
in
Yes,
this
Himanshu.
question, I have a doubt. Like I have read in two codes for this. Can you check that? Like paste it on the screen so I can tell you.
Himanshu, I will check at the end of the session. I mean, when I stop the streaming, I'll get back to your doubt.
Okay.
Yeah,
All the
yes,
personal
sir.
queries I'll handle at the end of the session. Sudhanshu.
No issue, sir.
Okay, okay. So, I mean, this question could be done without using recursion also. I mean, almost most of the questions can be, but still. So, I'll wait 2 minutes. Guys, should I start?
Yes, sir.
Yes, sir.
Okay.
Sir, before writing, can you explain the question, sir? What it is asking?
I mean, just a second, I'll use a whiteboard only. Okay, guys. So I mean, this is a polynomial function. You guys already know this, right? Okay. This x and the coefficients. So what we're given is we have a list of coefficients that a0, a1, a2 like this is provided, and a value is provided, and this is our x. So I mean we just have to put the coefficients and the value. I mean we just have to replace, suppose a1 is 1, just I'm just taking an example. Suppose we have 1 2 3, then all we have to do is 1 raised to 1 into 5 raised to 0 plus 2 into 5 raised to 1 plus 3 into 5 raised to 2. I mean, we're just increasing the powers, and these are just the coefficients. Manish, is this clear?
Yes, sir.
Yes, sir.
Okay. So we have a list of coefficients and the value of x for which we have to calculate. So if the length of list is 0, I mean, then we just have
Return 1.
0. I'll get back to this again. Else, so guys, I'll explain in this. Guys, just look, take a look at this code. I'll go to the whiteboard. Okay. So I mean, let's take a look at this function. Okay, so can we think of some recursive solution? Like, can you think of factoring something like we have a0, and then all these terms have x in common. So x into a1 plus a2x, 2 became 1,
So if we take out
and now
x, it
3
becomes the
became 2.
first statement again. The
Yeah,
first.
so I mean, this is our L0 and this is our x. Now again we can factor x, right? We had a0 plus x plus a1. Again take a x in common. You'll again have a2 plus a3x similarly. I mean, you'll get till length is 0, and then you have to return 0. This is our base case. And if it after that we'll get L0, so we'll add this, and for the rest we'll multiply by x again. Guys, is this clear?
Yes, sir.
Any doubt, please?
No, sir.
Okay. Write a recursive function named power that accepts a square matrix and a positive integer, and we just have to return a raised to m. Okay. Again, I'll wait for 2 minutes.
Sir, in the above question, you are
Yes,
not
Anish.
raising it to power.
Himanshu, I explained, right? I mean, x is being multiplied with everything except the zeroth element. So what will happen is L0 is not multiplied by x because x is raised to 0. After that, x is multiplied to all the terms. But what will happen in the second iteration is again one element which is already multiplied by the x from the previous call, right? That is again left out and x is multiplied to all other elements. So what will happen is the first is multiplied by x raised to 0, I mean nothing. Second is multiplied by x, then x squared, then x cubed. I explained on the whiteboard, right? Do you want me to explain again?
No, I will watch it on YouTube.
Guys, should I start?
Sir, here we can like define multiplication of that a square like and then call it recursively for if
Okay,
there are more
just
powers.
after do a, we'll have another function multiply matrix. So what we
Yes, sir.
can do is we'll use the power function again. So what will be a recursive call? Power of a and m minus 1. So and after that we'll multiply a with our result.
Yes, sir.
So I'll get to the coding part just a second.
We did same thing
So
before also without recursion. We just have to like introduce recursion.
I mean, almost all these questions in the PPS can be solved much easily without using recursion. But some problem like towers of Hanoi cannot be solved without recursion. So it's
Yes, sir.
better that you go at it.
Okay.
We'll have such questions in the OPP also that you'll have to use recursion.
Okay, sir.
Okay, let's start. So first I'll write the code for multiplication of two matrix. Hopefully everyone remembers this from the previous weeks. So I mean, since we'll just multiply it a and m minus 1, so we know the dimensions for a and b will be the same, right? So let's just initialize an empty matrix. Okay, so this is just a matrix of all zeros, and we'll have to use three loops, right, for matrix multiplication because we have both are two-dimensional matrices. So I mean, Cij, we'll have to add a ik into bkj, and we'll have to add this to our Cik. I mean, you guys know how matrix multiplication works, right? Or
Yes, sir.
I mean, use the whiteboard.
Sir,
Yes, Subrat.
sir, what will be the second, what is the second parameter b in the mul function?
So I mean, we have to multiply two matrices, right? A and B.
Okay, okay.
Guys, any doubt in this, or should I proceed?
No, no.
Guys, this code is clear, right?
Yes.
Yes, sir.
Guys, any doubts in this? Should I
No,
explain it
no.
on the whiteboard? Sure, guys. Should I move on?
So,
Yes, Bhumika.
so in that from fifth to eighth line, then first I will be zero, then J will be zero, and then K will be iterate from 0 to 2. Like if N is 2. Like I was getting
Yeah.
confused here in the previous week also, but I forget to ask this. And
Okay. So, I mean, it's pretty easy, right? Suppose you have 2, 2, 2 matrices. So, I mean, for matrix multiplication, we'll have to do this, right? This and this. So, n for this, n for this, and again n for this. So, what the outer loop will do is we have three loops, right? First, second, and third. First, we'll go through this, then this, and then we'll have to add this one element at a time, right? One, two. I mean, Omega, is this clear?
yeah, so I just have doubt over that values, that how it will iterate. Like I will be
So
first
let's take an
constant, then
example here. So for I and range n, so first will be 0, right? J will be 0, K is again 0. So this is our resultant matrix. So Cij, this element is equal to this initially 0, right? We initialized all elements to be 0 before. 0 plus Aik. This element 1 into this element 5. Okay. Then for k in range n will go to 1. So I mean 0 plus we aren't finished with this yet. Okay, we'll have to come back to this. So for this element 0 comma 1, okay, 0 plus aik 2 and b okay. uh, I'm sorry, I mean aik bk guys. Guys, this should be bk. Manchu, you should have reminded me.
What you did
Yeah.
earlier, sir? I missed it.
Sir, I wrote BIK. I just repeated this, which is wrong. I mean, we'll
Okay.
have to go L shape, right, for matrix multiplication.
Yeah, sir.
Guys, let's start the explanation again. And we have already initialized the 0 matrix. Okay, 0 0 0. So first, in first iteration all are 0. So for 0 comma 0 in C, we'll have to add 0 comma 0, add to 0 aik and bkj. So this element and this element 1 into 5. Okay, in the second iteration, remember this C00 is not yet done. We'll have to add other elements also in this. For next iteration, we have 0 comma 1 for C. Again, we are adding this and AIK 0 comma 1 and BKJ 1 comma 0. 0 comma 1 we'll have this, and we'll have this 3 into 7. Okay, we're done with K. We'll get back to J, and J will this time will be 1. And for we are done with 0 0 0 0 0 1. We are here. So again 0 1 0. Okay, guys, clear till now?
Then K will again take the value 0 and 1.
Yeah, I mean we'll have 0 1 1. Then we'll have 1 0 0. So you can see the pattern, right?
Mhm.
I mean
Yes.
0 1 0 1 0 1
Yes, sir.
0 0 1 1 0 0 1 1. This we have 4 times 0, we'll have 4 times 1.
Yes, sir.
Bhumika, is this clear or
Yes.
should I continue?
No, no, sir. Clear. Thank you.
Guys, everyone is clear with the explanation, right?
Yes, sir.
Okay. We have a multiplication of matrix. We have to write power. So I mean power can be done easily after we have written this multiplication code. That we have to raise a square matrix A to the power m. So I mean we can check if m is 1. So any matrix raised to 1 is the matrix itself, right? If m is 1, then just return A. And if it's not, then what we can do is A and m minus 1. So I mean we are raising A to the power m minus m. We know we can multiply this. Guys, is this clear? If m is 1, if we have to raise the matrix to the power 1, we are returning the matrix itself. If it's not, raise A to the power m minus 1 and multiply it with A. Guys, is this clear?
No, sir. Line number 16, can you explain again, sir?
Okay, okay. Okay, so this code is clear, right? How we are multiplying two matrices.
Yes, sir.
Okay. So, what is the base case for a power that if we have to raise a matrix by 1, that is just the matrix itself, right? If the power is 1, then we are
Yes.
just returning the matrix. Okay. If the power is not 1, suppose we are given a matrix A and we have to raise it to the power 3. So this is same as A square into A, right?
Yes.
Which again is equal to A into A into A. So
Yes.
now you can see the base case, right? So what we are doing is we are multiplying A raised to m minus 1 into A, because this is same as AM, right? Manish, Sudhanshu, is this clear?
Sir, why not directly enter M?
So I mean, how will you do the multiplication? I mean, suppose you have this matrix, how will you raise it to the power 4 directly? So you'll have to do this, right? 1, 2, 3, 4. You'll have to proceed one step at a time, right? I mean, first you can calculate this. You can get your answer, then you can multiply with this, and then again you can multiply with this.
Okay, sir, got it.
Guys, is this clear?
You can explain the last line
Sir, how are these
written.
two functions working, sir? One is inside the other, right? The power m minus one
Subrat,
is.
these are two separate functions, right?
Yes, sir.
This is the recursive call. I mean, we similarly this did this in insertion sort also, right? Insert and I sort.
Yes, sir. Yes, sir. Gotcha.
Okay. No, no, I'll explain again if so many people have a doubt.
Sir, can you please use some other pen,
Uh, what do you mean?
some other color pen?
Okay. Is this fine?
Yeah, sir.
Yes, sir.
Okay. So we have a matrix. We have to raise it to the power m. So that is same as raising it to the power m minus 1 and multiplying it with a, right? You guys understand this?
Yes, sir.
So this is the same, right? So we want am. So suppose we get to the base case that a raised to 1. Then we don't have to do this. Then we can directly return a. But suppose we have
Yes.
a raised to 3. Okay, so it will come here. What this will return is multiplication of this power of a raised to m minus 1 into a. Okay, so this will be a square and a. So again it will go here. A square will become a, and in this after this iteration raised to 1, right, this will return a. So a multiplied with a, this will return a square. This a square value multiplied with a, this will return a. Is this clear now?
Yes, sir.
Yes, sir.
So brother, guys, is this clear? Any doubts?
So it is like
No,
how
sir.
we do multiplication and raise power. A, then a square,
I
then
mean,
a
it's
cube.
not like you're raising 3 raised to 4, right? You can do this for 3 raised to 4 also.
Yes, sir.
Okay. But I mean, this is matrix multiplication. So how else will you calculate, I mean, any matrix raised to the power 4, right? You will have to
Yes,
proceed 2 at a time.
yes, sir, clear.
Guys, any doubts?
No, sir.
Okay. So we're given a square matrix and we have to find its determinant. Okay. So you guys know how this works, right?
Sir, do we need to find determinant for only 3 cross 3 matrix or for the general any size of
I mean,
square?
we can general case, right? In
Okay.
Guys, the question is clear, right? You guys know how.
Yes, sir.
Mm,
Yes, sir.
Yes, sir.
So we can make use of
okay.
that minor matrix which we used and call it for each element in the first row.
Yeah, and guys, I mean, the example given is wrong. Minus 1 raised to power will be 0 plus 0 instead of 1 plus 1. Since we are doing zeroth indexing, right? So, I mean, just decrease both the numbers by 1. The second will be 0, 1. The third will be 0, 2 in the example.
Yes, sir.
Sir, but if we reduce that, how that power work will not work properly, right? Like zero and
No, we're
zero.
reducing both by 1, right? It won't change the value.
Oh, acha. Okay.
Sir, they are using 1ds indexing for this. That's why it is written like that.
So that is I told you, right? That is, I mean, we'll use zero bit based in indexing. I mean, just add one to both the powers. I mean, it won't make a difference, but it's written in just the line above that we have used zero based indexing.
Okay.
Yes, sir.
Okay, I'll wait 2 minutes.
So,
Yes, Bhumika.
is this question related to maths too?
I mean, not really, right? You guys know how determinant works, right? I asked you if anyone has doubt in the question. Okay, I'll explain it just a second. Guys, anyone else have doubt in this question?
No, sir.
No, sir.
No, sir.
So I mean, Bhumika, you know how to open this determinant, right? We can open it by row or by column. So first, let's start by row. We only have to implement one of them in a solution. That A, if we have A, just don't use this and don't use this. Use this matrix. A into EF HI. So you'll alternate with the plus signs. This is our original matrix, right? So we used A, now we added to B. Remember, alternate with the plus and minus sign. B, just hide this row and hide this column. D, F, G, H, and D, F, G, I. And now
Come.
alternate. Now C, hide this and hide this. So D, E, G, H. So now for a 2 by 2, we know what's the determinant. It's AI minus FH, right? Bhumika, is this clear?
Yes, sir.
Guys, do you want me to wait or start? Others, could you turn off your mic? Others?
Sir, lot of apologies.
Yeah, it's okay, it's okay. Guys, any doubts in the question?
No, sir.
No, sir.
Or do you want me to wait 2 minutes or start with the question? I'll
We
wait
can
2 more
start.
minutes. Okay, okay. Let's start. Okay. So guys, so this EFHI, DFGI, I mean, we can use the minor matrix. I mean, it's given as a hint also that week 7 GRPA3 was that. So, I mean, you guys know how to code a minor matrix.
Yes, sir.
Yes, sir.
Does everyone know? Sudhanshu, Manish, Bhumika, Subrat, you guys know how to code a minor matrix.
No, sir. I don't know. No, sir.
Yes, sir. I know, sir, because I take math too.
Um, okay, I mean, I'll just write a one-liner code for people who do. Guys, is this code clear? Or do you need me to explain it?
It is using string slicing and skipping that ith element and jth element, right?
Yes, so we're using the list comprehension to skip the ith row and the jth row. Guys, is this code clear?
Yes, sir.
No, sir.
So can you explain, sir?
Okay. Yes, yes. So we have three inputs. We have this matrix. So let's just take an actual example. Okay. So we have this matrix as our input. I comma j will be values for the row and the column respectively. Suppose we want to remove this row and this column. So let's look at the inner part. That what this is doing is we have a two-dimensional list as our input, right? So till I and I plus 1. So you guys know when we use this, I will not be included, right? So we're skipping the ith column and row, again we're similarly doing this for the row that we're going till j, that is j minus 1. I mean, sorry, we're skipping this row. Guys, is the code clear now? Guys, any
Yes, sir.
doubts?
Yes,
No,
sir.
sir.
No doubts, right?
Yes.
Yes, sir, no doubt.
So we have the code from minor matrix. Okay, and now we have to write a function for determinant. Just a second, guys. Yes, guys. So we have to find the determinant of this matrix. Let's just get the dimension. We know that to find a determinant, it must be a square matrix. So suppose we have a 1 comma 1 matrix, and I mean the determinant is directly that element only, right? Right? It's the base case clear.
Yes, sir.
Okay. Or else let's initialize it to 0 first. And
Sir, you are reinitializing the name of function. Will want this produce error?
which function?
Det det, and you are assigning it to zero again.
I mean, a function name and a variable name can be same, right?
But
I mean,
it,
unless you
Sometimes
use
it
determinant, you don't give the
produces it.
brackets. This and this will be different, right?
But sir, I have seen there is sometimes it doesn't.
okay, sir, try it. Maybe it won't produce error.
Let's just use the. So for, I mean, I told you, right? We can open the matrix using a row or using a column. So B plus is equal to row. I'll write the code and then I'll explain it to you. Okay. So I mean, we're just using this 3 comma 3 matrix. So I mean, J will iterate over n, and then determinant of the minor matrix will be this part, and I raised to will be is this part. Guys, is this clear, or do I need to explain on the whiteboard?
Sir, explain.
Okay.
Sir, try to run that. I have written somewhat similar code, but mine was giving me incorrect output.
Okay, Manchu, let's run it first. So let's just give this as our input. 0.
Sir, matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 should produce 0. Check with that.
Okay, it is loading. Just a second. Oh guys, I just forgot to even. Okay, this is working fine. And Himanshu, what were you saying?
Matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. But mine was not producing. I also written
Okay,
somewhat.
show me your code at the end of the session.
Okay.
So you guys can see, right? The row is 0 for all the cases. So we are opening a matrix by its row. So what we want is 1 into this, exclude this row and this column. 5, 6, 8, 9. Alternate between plus and minus sign. Minus 2. Skip this row and this column. 2, 4, 6, 7, 8. This 3, 4, 5, 7. Okay, guys, this is batch rate. So what this code is doing that we had only one element, then it's just returning that element. I mean, suppose we had this matrix. So I mean, the determinant of the matrix is that itself. But if not, then what we're doing is we are opening by row. This plus sign, I mean, you can add this rate. Don't look at the minus sign right now. Just add all these three. I mean, suppose you had 1 minus 3 plus 2. You can do 1 plus minus 3, right?
Yes, sir.
Okay. So minus I raised to the power of j. So I mean j in range n. So we have j in range 2, right? Range 3. So 0, 1, 2. So minus 1 raised to 0, we'll have plus. Minus 1 raised to 1, we'll have minus. Minus 1 raised to 2, we'll have plus. You guys understood how these we got the signs? Minus 1
Yes,
raised to
sir.
1. Okay, that into m0 into j. So in the first row we are just iterating through the columns 1, 2, 3. This is our first row, right?
Yes, sir.
So we'll have 1, 2 and 3, and determinant of the minor matrix excluding the row 0 and j. So in the first case, for row is 0 for all the cases, and we are opening by row, and we're iterating through the columns, right? This j. So first case we are at 0, 1, 0, 0, 0, 1, and 0, 2. So what will happen is we have this matrix, right? Okay, so we are giving this as our input to a minor matrix. What was minor matrix doing is we are taking a matrix and we are returning everything except the excluded row and column. So we want to remove for 0 0. What will happen is we'll remove this and this. So we'll get 5 6 8 9. So this will go here 1 into 5 6 8 9. For 0 1, what will happen is for this row and this column we'll have 4 7 6 9, and this will go here. Understood, guys?
Sir,
Guys,
if
yes,
we
Himanshu.
take base case of 2 cross 2 matrix like A into D minus B into C, we take this base case, will this work?
I mean, this is also a 2 cross 2 matrix, right? 0 comma 0. I
Uh,
mean, we're
no,
indexing twice.
index.
Length will be
I
just,
mean,
I mean,
a matrix having 2 rows and 2 columns, a square matrix of 2 rows and 2 columns, we take it as a
okay.
base case. Yes,
So what will be our base case? This is, I mean, this is what this is doing, right?
yes, but like in this question, they have given like matrix determinant of 2 cross 2 matrix is A into D minus B into C. In the question, it is
So I
given. So,
mean, determinant is only known for, I mean, you can only calculate for a 2 by 2 directly, right? Else you'll have to use this method that
so can
alternate with the
we
plus minus. Yeah.
can we use the minor function to convert it into like 3 cross 3 to 2 cross 2 and then compute it directly without going to 1 cross 1?
Mm,
Is it
Himanshu,
possible?
I'm getting your doubt. I mean, 2 cross 2, A, B, C, D, we know how to calculate, right? This is AD minus BC. This is our determinant.
Yes, sir. Yes, sir. So can we take this as base case?
Mm, I mean, that technically, I mean, we're calculating this, right? We have a 3 by 3. So, I mean, we are splitting it. I mean, one, we are taking this 2 by 2. Then we are taking this 2 by 2. Then we are taking this 2 by 2. If we take the base case, then how will we get the coefficients, right? Because we still have to use that. In a recursive call, you use the coefficients, right?
Okay.
So that is why I mean I'm just multiplying it here directly that element into the determinant of the 2 cross 2,
Okay.
and we are adding it to a determinant D.
So maybe this is the fault in my approach. I was using a direct of 2 cross 2 determinant instead of going to 1 cross 1.
Guys, any other doubts in this?
No, sir.
No, sir.
Sure, guys, no doubts, right?
No, sir.
Will this approach work for 4 cross 4 also?
Himanshu, let's get back to this question at the end.
Okay.
I mean, we can modify it, right? But then we'll have to first divide 4 by 4 into 3 by 3. Then again for 3 by 3, we'll have to use this code. I mean, each time we'll have to decrease it by 1.
Okay.
So, okay, we have come to the last question. You have a logo that has a finite number of coins. Each coin has some positive integer engraved in it. You wish to draw a subset of coins whose total worth is exactly S. Okay, write a recursive function named subset sum. Okay, guys, so this is a difficult question. I'll wait 5 minutes. Is the question clear to everyone?
No.
Guys, you don't understand the question?
I'm not understanding what is the condition for returning true.
I mean, we'll have two cases, right? That one, we'll think of let's think of a recursive case that, I mean, for the zeroth element, either we can include it in a sum or exclude it. So if including s, I mean, we want it to be less than our sum, right? If it's greater than our sum, then we'll have to exclude it. If it's less than our sum, then we can again make a recursive call to add some other element. So we'll have two things, that either we are including it or not including it. We'll have two recursive calls. Guys, is the question clear for everyone?
Yes, sir.
So we will proceed. I mean, all coins have a specific value and we want a specific sum. So suppose we have 5 coins. First, we'll look at first coin. If the value of the first coin itself is greater than sum, then I mean, we cannot have, I mean, those, then we'll have return false. If it's not, if it's less than our sum, then I mean, we'll make a recursive call to first include it and then calculate the sum. And the second case is to exclude it, because it can happen, right? Suppose we have the sum is 4 and two of your coins have the same value of 2. So I mean, you can include the first coin, use the second, exclude the second coin, or you can exclude the first coin, include the second coin. Guys, is this question clear?
Yes, sir.
Yes, sir.
So, sir, we will
Okay.
include some coin one at a time and check if it the current sum is equal to s and proceed further and make the recursive call.
Yeah, I mean, but not exactly s. We want less than equal to s, right? Because it can
Yes,
happen that till now our sum is less than that, but if we our list is not empty, it can happen that some other adding some other coin makes it equal to s.
yes, sir. Clear.
Okay, guys, try to solve this question. I'll wait 2 more minutes.
I can solve, but not recursively in nested it will.
Himanshi, I mean, that is the point of all the PPAs and VK, right? To get you.
Yes,
I
sir.
mean, Himanshi, but I don't think this question can be solved recursively unless you use brute force. So that will be the most inefficient solution.
Yes, sir. I mean, nested for loops
Yeah,
can
so
be.
brute force will obviously work, but it will be so inefficient, right? You'll be trying every combination. Suppose you have n coins, you'll have to calculate so many possibilities, right?
So maybe the point of this PPA is to show how bad recursion is in this type of questions.
No, no. I mean, recursive case is better. What he's saying that
Oh,
he'll try every possible combination. That
oh,
suppose you have 5 coins, then I guess your time complexity will be 2 raised to n for your solution, because we'll have nc0 plus nc1 plus nc2. So that is the sum of those combinations. You know from maths 2 is 2 raised to n, right? So that is like just worse than n factorial. Our recursive case will be much better. Again, I'll wait for 2 minutes.
If L becomes empty, then we should return false. If we get the sum, then we should return true. And these two become the base conditions. What should be the recursive?
So I get your hint, right? You'll have to write two recursive. First, we'll include it, and second, we'll exclude it. So what we'll return is include or exclude. If either of those is true, that either including the first coin we have the sum, or excluding the first coin we have the sum. In any case we can get the sum, right? We just have to return true. Okay guys, let's start with the solution.
Yes.
S is our sum and L is the value of our coins. So first let's write our base cases. Let's suppose if the sum is 0, right? I mean, if the sum is 0, just don't include any coins. So it don't. I mean, is this understood? I mean, when we'll write the recursive cases, right? We'll when we are including it, we'll deduct it from our sum. So when it is exactly 0, we have already gotten to the sum, right?
Yes, sir. If list is empty,
Okay.
return false.
Yeah. So if a list is empty, so you guys understood not L, right? I mean,
Yes, sir.
we
Yes,
can
sir.
easily
Boolean.
check if the length is, yeah.
If
So
L
if
is true, so
not
this
L,
is false.
I mean, we can use this one. Just in case. If the list is empty, and we have already checked on line number 3 that our sum is not 0. In that case, we have already used our coins and we have not gotten to the sum. So we'll have to return false. These are our base conditions. So what I told you, right? We have two recursive calls. So first for include, it initialize both to be false. So first, let's say we are including the L0. The first thing we are including it. But I told you, right, the sum, the value of that coin should be less than S. Because if it's greater than S, then we'll just exceed the sum just by using one coin. If it's less than S, then I'll write the code first and explain. Okay. Uh, I told you that first is we are including it. So suppose we have already included a coin which has a value of 2 and we want the value 5. But we have already included 2, right? So we'll remove that coin and we will deduct it from our sum. So we have removed coin 2 and we have subtracted it from our sum. Is line number 11 clear?
Yes, sir.
Everyone, is line 11 clear?
So can you repeat what you said? What?
Yes, yes. So I told you we have two cases. In this case, we are including a coin. So if we are including the coin, we have to deduct it from our sum, right? Suppose we
Yes.
have 5 coins and we have a sum. Suppose we are including the first coin to get to our sum. So suppose our sum is 10 and the value of our coin is 3. We have included it, means now we only want a value of 7, right?
Yes, sir.
And we have to, we have already used this coin, so that is why I'm going subset L1 is 2. So I mean I'm excluding the first coin and I'm checking if the other coins can get to a sum that is S minus L0, that is 10 minus 3 7. Can those other coins be used to get to the sum 7? Okay.
But sir, it won't work in cases like if you have 6 coin, first coin is 3 and rest all are 2s. So if you include the first coin and the sum is
So
10.
that is why the code is not finished, right? I also I told you, right, we'll have two recursive codes. First we're including it. In the second case, we'll exclude it. It can happen, right? I mean, suppose we have the sum is 6 and we have 3 coins, each of value 3. So you can choose any two to get to sum 6, right?
Yes, sir.
So I mean this will be a return case that we just want to check if we can get to the sum or exclude. If either of these is true, then our answer is true, right? So we're done with the include case. Now let's look at the exclude case. I mean, exclude case is just that we'll not deduct it from the sum, right? In the first case, we included it and we removed the coin. In the second case, we'll just remove the coin. We'll not subtract it from a sum. Is this clear?
Yes, sir.
Guys, any doubts in this question?
Sir, when will we exclude this?
Um, Subrat, when will we exclude this? I mean,
Like for which number? I mean, if it is greater than in that condition, right, sir? When it is
I
greater
mean,
than.
it's not, we don't really want a condition, right? Suppose, just think of it like this, that we want a specific sum and we can use or not use a coin to get to that sum. So in the first case, we're using it, we are including it, and we are checking if we can get to S minus using that coin. And the second case, we're just excluding it and can we get to the sum using the rest of our coins. So, I mean, those are the only two cases possible, right? I mean, either we'll use the first coin or we'll not use it.
Yes.
Similarly, either we'll use the second or we'll not use the second.
Yes, sir. Clear.
Guys, do you need me to explain this on a whiteboard?
Yes, sir. I mean, yes.
Okay.
So can you take that 3 and 2 to 2 case? It will be easier to follow.
Yeah, I'll take an example to help you guys understand. So, suppose we have a specific sum 8 and we have coins. We have these 5 coins and we want the sum 8. So, I mean, how can you get to a sum? So, just think of it like a PNC problem, right? Either you can take 3 or you can't take 3. Either you can take 2 or you'll not take 2. Either you'll take 5 or not take 5. And you're adding this. Do
Yes,
you
sir.
understand now what the question is asking? That either if you take 3, then I mean, for rest of it, just take 3 to the other side, right? Now, using the rest of the coins, can you get to 5? This is your include condition. What your exclude condition is, the sum remains the same, but without changing the sum, with using the rest of the coins, can you get till it? This is your exclude condition. Is the question clear now?
Yes, sir.
Any doubt, guys?
No, sir. Sir, how we can do so that it returns that specific set, like which coins are used, like a print statement there.
I mean, we'll have to keep track in a list, right? I mean, we can just a list of booleans that if we are including it, initialize that to be true, and if we are excluding it, initialize it to be false. So suppose in the end you'll have true, false, true, true. So then you can use your original list to get I mean, which coins add up to that?
Maybe a dictionary with Boolean values and keys as coins.
Yeah, I mean, whatever.
No, you can't. You have to use reverse. Oh yeah, that would also work. Yeah.
Guys, any doubts in this question?
No, sir.
So it will take time to process. Like I have to do it myself also. Then I can.
Guys, you were not solving with me. I That is why I was waiting for 2 minutes for every question. To hear me? You
Sir,
can try, then we can get to the solution.
2 minutes are not sufficient for this question. It will take time. So I will practice and come on next session if I have doubt.
Okay, guys. So this was the last question of our PPA.
Sir,
Sir, I have doubts on the other PPS of this week. I have pasted on chat. So
PPA 1 to 9 Cobra ma'am discussed yesterday, right?
no, no, not from. I mean 11, 12. I think the question you told here that
Okay,
those
okay.
questions.
Bhumika, you were saying something.
yes, sir. Do these type of questions come in OPP?
I mean, the last question, most
Yep.
probably not. I mean, the difficulty won't be this much. I mean, two recursive case, I mean, it will be, I mean, OPP questions are much easier, but I cannot guarantee that we won't have one or two difficult questions.
Okay, sir.
But I mean, as long as you practice the PPAs and GRPs, that is enough. Guys, any other doubts?
No, sir.
Okay, guys, then I'll. Okay, guys, then I'll meet you in the next session.
ये बिना स्ट्रीमिंग रोके क्यों चले गए? यूट्यूब पे क्लास चल रही है. शिव.
Yes. So until and unless everyone leaves, that stream would like continue for hours.
Hey, Shiv. Uh,
Yes.
leave it. uh, इसमें ही शिव उसके नाम के आगे ही लिखा हुआ है.
Yeah, I can access that, but that would be unethical.
Okay.
It's better to ask.
Hmm.
We can do these kind of session like where we solve like just the students. but we won't have that time to do it.
I think we should make ourselves for that.
Suraj, can you also give your email or something?
Mm, same, that is 232. It's
Oh
written on
yeah,
the.
but yeah, that is okay. Yeah, I will. If you, yeah, you are saying it, then I will. Okay, I will take it. Okay, let's leave the class.